Okay, everyone, we're on our final page of notes for lesson 2. I told you there was a lot going on, and I hope you've enjoyed having them in 4 chunks instead of one giant long video. In this video, we're going to look at tangents within a circle and what kind of relationships are formed in the circle. So before we start, let's make sure we understand what a tangent line is. A tangent line intersects the circle at exactly one point. It hits it right on the edge of the circle, and it keeps zooming right on by. That point is called the point of tangency. Okay, I feel like that kind of makes sense. This tangent line hits at this point, so that's called the point of tangency. Okay, a tangent line, or any line that is tangent to a circle, will make a right angle at the point of tangency. So a line is tangent to a circle if and only if it is perpendicular to a radius that's drawn to the point of tangency. You get to make a right angle there. Well, I'm just going to draw something in so you see where we're headed. If I can draw in a right angle there, then I can draw in a right triangle, and now I'm starting to unlock a lot of right triangle stuff, like Pythagorean theorem, for example. So let's take a look at our first set of problems. I'm going to make a little note right here. You are definitely going to use some Pythagorean theorem, okay? All right, the first set of directions says for us to determine if AB is tangent to circle P. So the question is this a tangent line? Is AB a tangent line? Now, we can't go on just the picture. Of course, we've got to use some math here. Well, if it's a tangent line, then it's going to have a perpendicular relationship with the radius, which means it's going to form a right angle. Well, the only way for us to know if that's a right triangle is to use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So if these 3 side values work in the Pythagorean theorem, then that'll mean we have a right triangle, which means that line is tangent. So let's plug them in. A is my small, so that's 8 squared. B is my medium, so that's 15 squared. C is the hypotenuse, that's 17 squared. All right, well, 8 times 8 is 64. 15 squared is 225. And 17 squared is 289. If I add 64 and 225, I get 289. So this works out. Because the right triangle was formed, that means that this is a perpendicular relationship, which means AB is tangent. All right, let's try again over here on number 2. Our question is this truly a tangent line? And if so, it will form a right triangle. So let's check out our Pythagorean theorem. A squared plus b squared equals c squared. All right, A is our short leg, that's 11. B is our long leg, 14. C is our hypotenuse, which is supposed to be the longest value, so it can't be 5. Notice that 5 is just here on the exterior. We also have a radius of 11. So that would make the entire hypotenuse 5 plus 11, which is 16. So let's see if this works out. 11 squared is 121. 14 squared is 196. 16 squared is 256. If I combine the 2 values on the left, 121 plus 196, I get 317. That is not equal to 256, which means this is not a right triangle, which means that line is not tangent. All right. So that point of tangency should house a right angle if the line is tangent. Now, our directions are changing a little bit and a variable is introduced. The directions say, if JK is tangent, so they're giving us that information, it's given, this is a tangent line, then we need to find the value of x. Okay, well if JK is tangent, if this is a tangent line, then our right angle exists, which makes this a right triangle. So I'm still using Pythagorean theorem. A represents the short leg, which is 7 here. B represents the long leg, which is 19. C represents the hypotenuse, which is what I am trying to solve for. Take a moment and complete the Pythagorean theorem to solve for x. If you got this far and you don't know how to solve for x, let's talk about it. I've got 410 is equal to x squared. In order to solve for x, I have to use the inverse of a square, which is a square root. So I need to take the square root of 410. Since the directions don't say whether this has to be an exact value or rounded value, I'm going to go the easy route and use my calculator to round this. That is rounded to 20.25. All right, let's check out number 4 here. If JK is tangent, then it builds a right triangle. Since there's a right triangle, I can use Pythagorean theorem. In Pythagorean theorem, the A stands for the short leg, which is 11. The B stands for the medium leg, which is x. And the C stands for the hypotenuse, which cannot be 7. Don't get tricked. That 7 is just the exterior piece. 11 is going to swoop around to represent the radius, so that makes the entire hypotenuse 11 plus 7, which is 18. Take a moment and solve for x. My final answer for x is 14.25. Okay, we have one more property about tangent lines that's very important to talk about. Okay. Our property here is that if two segments from the same external point, so we're talking about point B, are both tangent to the circle, then those segments are congruent to one another. So if you have two tangent lines that come from the same point, then those tangent lines are congruent to one another. So here in this picture, AB is congruent to BC. Okay, if we expand that a little bit further, think about this. If we have this polygon, okay, a polygon is a shape. If we have this polygon that's drawn around or circumscribed around a circle, then all the sides are tangent, which means this goes together. The external point creates two tangent lines that are equal to each other. In fact, there are 3 of those situations. Both tangent lines that come out of C are equal to each other. Both tangent lines that come out of A are equal to each other. So we have a lot of congruent pieces here. Let's see how these are going to work out. What are we going to use here? All right, example 10 is not a circumscribed polygon. It does have 2 tangent lines that come from point B. By this postulate, those 2 tangent lines are congruent in length. So our algebra here would say that the 5x plus 23 is equal to 8x minus 19. Okay, well, I like to keep my x positive, so I'm going to move the 5x to the right. That gives me a positive 3x. That means if the variable is on the right, I'm going to move my numbers to the left. 23 plus 19 is 42. So I've got 42 is equal to 3x. I just need to divide both sides by 3. 42 divided by 3 is 14. So x is 14. You try number 11. I set these two tangent values equal to each other and solved for x, and I got an x value of 3. However, the question wants to know what's the length of PQ. So PQ is on the left. That means I need to take 3 and put it into the x position and simplify. 14 times 3 is 42, and 42 minus 13 is 29. Final answer, 29. All right, what about this problem down below? Now we're looking at the circumscribed polygon. So take a look at our notes over here. Every single exterior point holds 2 tangent lines, and those 2 tangent lines are equal to each other. So let's start with point E out here. Point E has one tangent line that's 16, which means it actually has 2 tangent lines that are 16. Now this is going to help us find the perimeter of the full triangle because we've got to find all these missing pieces. Now let's go down to point F. It holds one tangent line that's 9.5, which means it holds 2 tangent lines that are 9.5. And finally, D has an 11, which means there must be another 11. Now, when I want to find the perimeter of the shape, that means I have to add all 6 parts together. It's going to look like this. 11 plus 16 plus 16 again, plus the first 9.5, plus another 9.5, plus the final 11. All 6 parts must be added together to solve. So let's see, 11 plus 16 plus another 16 plus 2 9.5s plus the final 11 adds up to a total of 73. Let's look at our final example of the lesson. Find the perimeter of quadrilateral PQRS. Okay, let's see what we have here. All right, I'm going to start over here at R. There's one value of 27.1, which means there's 2 values, one for each tangent line. Now this 52.5 stretches across the entire figure. 27.1 is just from R to the tangent line. So if I want to know the rest of this value, which I do need to know so that I can transfer it over, I need to do a simple subtraction. 52.5 minus the 27.1. I'm getting 25.4. So this piece is 25.4. Now that's a tangent line coming out of S. So there's another 25.4 on the other tangent line that comes from S. And we're almost done. It looks like we just have this one little piece missing over here, but it has no congruent tangent line value yet. We're going to have to work our way around. The next tangent line I have comes out of P. It's a 23 length unit, so there's another 23 on the other tangent line. Now that entire length all the way from P to Q is 37.5. we've used 23 of that measure to get to the point of tangency. The other 14.5 goes with the second tangent line, which means there are two 14.5s. So now we have every single tangent line pair all the way around the quadrilateral. When I want to find the total perimeter, I need to add up all 8 pieces. So it's going to be a really long addition. I'm going to start on the top. That's 23 and 14.5. Moving to the right is a 14.5 and a 27.1. Moving to the bottom piece is a 27.1 and a 25.4. And then finishing up on the left is a 25.4 and a 23. 8 pieces total to add up. Almost done. 2 23s, 2 14.5s, 2 27.1s, and 2 25.4s for a total of 180. That is not 180 degrees. That is just 180, I don't know, inches around this perimeter, feet, miles, yards, whatever. All right, guys, thanks for hanging with me. Tried to warn you at the beginning that this was a lot of information on circles. You've hung in there. Happy studying.